studying a new chapter. The new chapter is all about polynomials, and we're starting with the simplest one that we actually have already done quite a bit with, and that's the quadratics. That's a second degree polynomial. You notice that the degree, when it's written in general form, we write it in descending order, right? And the degree is 2. Now, we talked about the standard form. We used it, in fact, a few sections ago, and you may recognize that the standard form actually shows us the shift. So if we were going to pick one to graph from, it'd probably be easiest to do the standard form. And it tells us the vertex, right? Because instead of the vertex being at 0, 0, it's moved over h and up k. Okay, so the standard form is the one that shows us the shift. And the vertex, we can read right off the standard form, it's just hk. Because of that, sometimes the standard form is called the vertex form. So, what we want to do today in this video is go from the general form. If I give you a quadratic function in general form, that you could change it into standard form. And that would tell you the shift and the stretch, and it tells you the vertex, it allows you to graph it. So there are times that this standard form can be very useful. Alright, so here's a quadratic in standard form, and we want to get it into, this quadratic is in general form, we want to get it into standard form, the vertex form. So we want to make a perfect square. So we call this process completing the square, and you should have seen this before. We used it in other things in previous classes. So what we want to do is we want to look at just this first part here, and I'll stick that 2 down here, but I want to make this a perfect square. Okay, and whatever I put in here, I have to kind of subtract it off again, so that what I've changed in the formula is nothing. So when I decide what needs to go here and I add it on, I'll just subtract it back off outside of the parentheses. Okay, so if you remember when we did, if we were squaring a binomial, the first term is the first one squared, and the last one is the last one squared. The middle one is the two of them together in half, right? Or doubled. The middle one is doubled because you use both of them twice, right? In other words, if we have a plus b squared, that would be a plus b times a plus b. So here I would have my a squared, right? And then I would have ab, so that's the first one and the last one multiplied together. And then I have it again, right? So that's why I have 2 of them. And then finally I have the last one squared. So what I want is half of this middle term will tell me what goes here, right? So I have my x already. That would be my a. And that's already there. But that means this 4 has to be 2 times b, right? And b is the thing that is in our second slot here. So if I half this, I just take half of what's there, the number part, right? Half of 4 is 2. And I square that. That would be 4. So that would be my, that's like my b squared. Okay? So that's how I always figure out what goes right here. I look at the middle term, I take half of it, and I square it, and that goes in the last term. Okay, well, I've just added 4 into my equation. I just took 4 and added it in, so now I have to subtract it off. So when you add it on, you have to subtract it off. So I haven't changed my equation. It's the same equation. Alright, now I made this a perfect square. So it's really x plus 2, which was half of that, right? This is my b. It's the square root of this, it's half of that. Squared, and I add these together, or subtract them, so I get -6. Okay, so this is my equation in standard form, or vertex form. My vertex is going to be -2, -6. Now, the reason that it makes it pretty nice to graph is, suppose I have this graph, I would go over to 1, 2, 3, 4, 5, 6. There's my vertex. It's the standard parabola. So it would look something like this. Alright, where it went over 1 up 1. Of course, I don't have my scale, my graph drawn very accurately, but you got the idea, right? So that's the general way we complete the square and change it into standard equation. So let's do another one. Okay, so in this one we want to do the same thing. We want to get it into standard form and state the vertex. So this time, if you notice, you got this 2 here that's different than last time. And in our standard form, if you remember what our standard form looks like, there's nothing inside the parentheses with the x, right? It's outside the parentheses. So this 2 has got to come out, and we'll put all the x's still inside. That means I got to factor 2 out of both of the x's. The number I can just leave out here. Okay? Now I just figure out again what goes here. So I'm going to take half of this, so half of that would be -3, and -3 squared is +9. So +9 goes there. Look what I've really added to this equation. The 9 is inside the parentheses, so I've really got 2 times 9. So I've really added in 18. So I have to subtract off 18. Okay, so now I've got this perfect square, which I made to be a perfect square. And then I've got 23 minus 18, so that would be +5. Alright, so in this one, the vertex is 3, 5. So I want you to notice that I'm writing the vertex as an ordered pair. That means it has the parentheses, and it has the x first, and then a comma, and then the y. That's what I mean when I say write something as an ordered pair. Okay, so this is in standard or vertex form, and this is the ordered pair that is the vertex. You notice that if I were to graph this, the vertex would be at 3 and 5, and it's skinnier, right? It goes up by 2. So instead of going over 1 up 1, you go over 1 up 2. It's going to be extra skinny up there. Okay, but that's how we put it into standard form when there is a number in front. There are times when that number in front will make us work with fractions. We can still do fractions. Don't let that scare you away. We can still do one. So let's try one with fractions. Okay, so here's another one. We have a 2 in front. When I factor out the 2, I actually get a fraction. Okay? So just the same, I look at this middle term here, and I take half of it. Well, 3 halves times 1 half, that's 3/4. And I square it, and I get 9/16. Okay, so I really have added in 2 times 9/16, so I'm going to subtract off 18/16. Okay, so now I have 2 times x minus, and it was half of this, right, or the square root of that, so that's 3/4. And then we would have 16 over 16 minus 18 over 16, so negative 2 over 16, which is, I could reduce to 1 over 8. Okay, so my vertex is 3/4 and negative 1/8. Okay, so it works the same. Yes, it can get kind of messy with the fractions, and you have to remember how to do fractions, but it works the same. We can do this to any quadratic that's in general form. We can complete the square, and we can put it into vertex form. So you might be wondering about why we want to find the vertex. Of course, graphing would help, but if we don't, I mean, it would be good for graphing, but if we don't have to graph, what else do we want to use this for? Well, let's come back up here to the first one we did. You notice that when we graph this, the vertex that we found right down here, it is a minimum on this function, right? So the x value is where the minimum occurs. The y value is the minimum. So in this particular function, we have a minimum of -6 that occurs at -2. And we could easily, to make it clearer, we could say it occurs at x equals -2. Just to be clear that it's the x value that we're talking about when we say where something occurs. Okay, so this is also a minimum, right? Because it opens up. If it opened down, we'd have a maximum. But this has a minimum of 5. It occurs at x equals 3. Okay, so that's the terminology that we would use. The x tells us where it happens. The y tells us what the actual minimum is. So in this one, the minimum is -1/8. That is the lowest this function ever goes. That occurs where x is 3/4. And that's what we use this for. Here is your quiz question for this section, is that I want you to change this quadratic, f of x, to standard form, right? And then state the vertex. So what I'll have you enter in Canvas is the vertex. Write it as an ordered pair and don't put any spaces inside the parentheses.